Very good morning, my dear friends. In today's video, we are going to learn about the sections of a square pyramid. And in today's session, we have this problem on the section of square pyramid. A square pyramid of side of base 30 and axis 60 resting on on its base and HP with a side normal to VP is cut by a section plane which is normal to VP and inclined at 40 degrees to HP bisecting the axis of the solid, and is asking us to uh, write down the sectional front view, sectional top view, front view and true shape of section, and is also asking us to name the true shape of sections. Generally, on problems on sections of these solids, particularly on pyramids and the cones and cylinders, they ask us to name the true shape of section. Friends, here you can see the pyramid is a square pyramid. That is to say, it has got a square base of the given side of 30 millimeter and it has got a height. So he says it is resting on HP on its base. So whenever any pyramid is resting on its base on HP, the axis of the solid is perpendicular to HP, obviously parallel to VP. And he says specifically that one of the side of this square pyramid is perpendicular to VP. In case of square pyramid, you should remember whether one of the side is normal to VP or one of the side parallel to VP or two base edges parallel to VP, two base edges perpendicular to VP. It's all the same. Now, let me write down the top view of the pyramid, which is a square of given side of 30 millimeter. So I am going to write down here a square of the given side. So this is a square, say, and it has got a size of 30 and we can just name the corners of this as A, B, C and D. So we will join these diagonals AC and BD so as to obtain O, the vertex of the solid. So friends, here whenever any pyramid is placed on HP and its base, you will be able to see all the slant edges of the pyramid. In case of square pyramid, you will have 4 slant edges, pentagon 5 slant edges and so on. Friends, corresponding to this top view, let us write down the front view of the solid. Just like laminar problem, project the lines from here, mark the center O1, the center of the base, and the axis, we are going to mark the height of the solid. Friends, the height of the solid is given to be 60 So I will just mark this O dash, the vertex of the solid, and join that vertex to these corners, namely A dash, B dash, C dash, D dash. And friend, this has got a height of 60 millimeter. The height is given to be 60, or the axis length is 60 millimeter. Friends, you have got the front view, you have got the top view of the solid. In the top view, OA, OB, OC and OD represent 4 slant edges, the top view of the 4 slant edges. Here in the front view, O dash A dash, O dash B dash, O dash C dash and O dash D dash represent the corresponding front view of the slant edges. O dash O1 dash is the axis which is perpendicular to HP. O1 is the center of the base. I'll just mark O1. Friends, we have obtained the initial positioning of the solid. Then he says it is cut by a section plane. A section plane can be assumed to be a very thin rectangular blade like thing. So it is going to bisect the axis. So before that, let us see how does a section plane look in the front view and in the top view. Friends, whenever any section plane is perpendicular to VP in any orientation 360 degrees, it is seen as a line in the front view, and its inclination with the HP is seen in the front view. Friends, in this case, this particular section plane is bisecting the axis. So I just mark the center of that height, that is at a distance of 30 mm. I just mark the midpoint of the axis, and here I am going to write a section plane which is normal to VP, means perpendicular to VP, and at an angle of 40 degrees to this HP. So I will write down a line here passing through the midpoint of that, and which is at a distance of, or at an angle of 30 degrees to the horizontal, sorry, 40. So this is the section plane that is cutting the solid into two pieces. So after we cut the solid, we have to retain the bottom portion of the solid. So like this. So I am going to retain the bottom portion to obtain the views of the solid, and then remove the upper part. Upper part means above the section plane, this part is thrown out. And friends, now let's see what that asked in the question. He is asking us to draw the sectional top view. We get the sectional top view when the section plane is cutting in the front view. That is, whenever the solid is cut perpendicular at any angle to the axis, you are going to get the sectional top view. If the section plane is above the XY line, you get the sectional top view. If it is cutting the solid in the top view, you will get the sectional front view, and so on. So what is the meaning of these points where the section plane is cutting? Friends, if you observe, you will see here the section plane named as SS, which is cutting the solid, no, has, or is cutting O dash A dash, O dash B dash, O dash C dash, O dash D dash. That is, it is cutting all the four slant edges of the solid. That means we are going to get 4 points in this section. So how to get them? So you have to go in order. So let us start from this point. That is, it is cutting O dash A dash. O dash A dash is cut here. So from this point, write a vertical line till it cuts the corresponding OA in the top view. So you get a point here. Likewise, O dash B dash is again cut here. You extend that line and get the second point. That is, I will say point number 1, point number 2. Friends, and the same line, O dash C dash is cut here. O dash D dash is also cut here. So draw one more line from there and get this point. So on O dash C dash, you are going to get 3, and O dash 4 dash, you are going to get 4. So basically we have got 4 points on the corresponding 4 slant edges in the top view. Join them by straight line. So I am going to join 1 to 2, 2 to 3, 3 to 4 like this. So friends, we got 4 points. After getting these points by straight line, hatch it or section it. So friends, here this complete figure, that is ABCD 1, 2, 3, 4, along with this remaining portion of these slant edges will represent the sectional top view. In the top view, you have the sectioning done here. So this is the sectional top view. And here friends, portion above the section plane, above SS, has to be shown by thin line, construction line. And this is called the front view of the solid along with the section plane we have shown. And friends, You have got the sectional top view, you have got the front view. We need to obtain the true shape of the section. True shape of the section. What's the meaning of true shape of the section? Whenever any object is cut by a section plane, the mirror image obtained by placing the mirror parallel to that section plane or section is called the true shape of the section. So friends, the procedure is very simple. Here, to get the true shape of the section, friends, I am going to draw a line parallel to the section plane anywhere convenient outside the figure. So I am going to draw a line here parallel to the section plane at any convenient distance, and from these points, that is 1 comma 2, 3 comma 4, the points where the section plane is cutting there, I am going to draw the perpendicular lines through that. So I am going to draw the perpendiculars to this line, say x1, y1 or whatever you call from these points. So I am going to draw perpendiculars. So these lines I have drawn are perpendicular to these x1, y1. Friends, on this I should get the true shape of the section or the mirror image of the cut portion in the true shape. So how to get, friend? To get the true shape, remember, you have to take the distances of the points 1, 2, 3 and 4 from this xy. So 1 is on this line at a distance of this much, 1 to xy. I just mark it there. That is point 1. Similarly, from x1, xy to this will give you 2. I just mark 2 here. So we got point 1 and 2. Similarly, on this perpendicular line, I should get 3. 3 is away. That is from xy to this 3. We are going to get this point 3 and finally point 4. That is from here to this point 4, this vertical height. Friends, we have got all the 4 corners. Join them by straight line. So I will join this by straight line, and you know these points. This is point 1, 2 in order. This is 3 and this is 4, friends. So I am going to section this true shape by drawing lines at an angle of 45 degrees to the horizontal. This will give you the true shape of the section, which you call it as TS. So after obtaining the true shape of the section, friends, there are some important concepts to be just understood. Friends, here you can just observe the distance 1 to 2 is equal to this distance. So this gap 1 to 2 is equal to this. Similarly, 3 to 4 is equal to this gap. So in some of the questions, what they do, they give you the true shape of the section and they ask you to find out at what angle the section plane has to cut the solid so as to obtain the true shape of the given size. So they will give you some dimension, maybe this is 20 by 10. What should be the section plane and at what angle it has to be cut. So in some more videos, I am going to tell you how to work out such problems also. Friends, this will give you the complete solution for the given question. And if you are happy with the presentation, please subscribe to my channel. Share this information with all your friends. Have a wonderful day.